Ever wondered how your muscles grow after a tough workout? Did you know that every squat, push-up, or sprint reshapes your muscles at the cellular level? Whether you dream of explosive power like a sprinter or marathon-level endurance, the secret lies in understanding how your muscle fibers adapt to exercise. Let's break down the fascinating science behind muscle fiber growth and how you can harness it to maximize your gains. Muscle growth, also known as hypertrophy, doesn't just make you stronger, it transforms your body at the cellular level. Whether you're lifting weights, running, or doing bodyweight exercises, your muscle fibers adapt and remodel themselves to match the demands of your activity. Let's start with the types of muscle fibers. Muscle fibers are the building blocks of your muscular system, and understanding their unique characteristics helps tailor your training to achieve specific fitness goals. Broadly, muscle fibers are categorized into type 1 slow twitch and type 2 fast twitch fibers, each serving distinct purposes. First, type 1 or slow twitch fibers. They are red in color due to their high myoglobin content. They contract slowly and less powerfully, but are highly resistant to fatigue, making them ideal for long duration endurance activities such as walking, jogging, and maintaining posture. These fibers rely primarily on oxygen-based aerobic respiration for energy and have an abundant supply of mitochondria and capillaries to support oxygen delivery and continued activity. These are designed for endurance activities like long-distance running or cycling. They are commonly found in postural muscles, such as the erector spinae, and are highly developed in endurance athletes. They adapt to training by increasing mitochondrial density, capillaries, and myoglobin content to increase their endurance over time. For example, marathon runners and endurance cyclists have a higher proportion of type 1 fibers. Second, type 2 or fast twitch fibers. These are further divided into two types. Type 2A fibers or fast twitch oxidative fibers have a pinkish red color and are intermediate in function between type 1 and type 2X fibers, combining strength and endurance. They contract faster than type 1 fibers but have moderate fatigue resistance. These fibers can utilize both aerobic and anaerobic metabolism for energy, making them adaptable for activities requiring a mix of power and endurance, such as middle distance running or swimming. They have a moderate to high density of mitochondria and capillary supply, allowing them to be trained for either endurance or strength. They're perfect for activities like middle distance running or high rep strength training. For example, a 400-meter sprinter or a high repetition strength trainer develops type 2A fibers. On the other hand, type 2X fibers or fast twitch glycolytic fibers are white in color due to their low myoglobin content. These explosive fibers contract very quickly and produce powerful bursts of force, but tire quickly because they rely on anaerobic metabolism, which leads to the accumulation of lactic acid. These fibers are suited for short, high-intensity activities like sprinting, weightlifting, or jumping. They have a sparse capillary supply and low mitochondrial density, making them less efficient for prolonged activities. Type 2X fibers are built for short bursts of power, like sprinting or heavy lifting. Hence, they are particularly prominent in muscles used for explosive movements, such as the quadriceps during a sprint. They improve with heavy resistance training, plyometrics, and high-intensity interval training. Training these fibers can lead to rapid increases in strength and power. For example, powerlifters, sprinters, and shot putters rely heavily on type 2X fibers. So, how do muscles grow then? It's all about hypertrophy. Muscle hypertrophy refers to the increase in the size of muscle fibers, which happens as a result of repeated mechanical stress or training, leading to the addition of contractile proteins like actin and myosin within the fibers. Muscle growth or hypertrophy is much more than a visual transformation. It's a complex biological process involving repair, adaptation, and rebuilding at the cellular level. Muscle growth or hypertrophy happens through two primary mechanisms, each with distinct effects on muscle size and strength. First, myofibrillar hypertrophy. This is an increase in the size and number of myofibrils, the contractile proteins within muscle fibers. It focuses on functional development, increasing the muscle's ability to produce force and leading to denser, stronger muscles. It is triggered by low repetition, high intensity, such as heavy lifting, which is common in strength-focused training such as powerlifting. Second, sarcoplasmic hypertrophy. This is an increase in the volume of sarcoplasm, the semi-fluid substance surrounding the myofibrils. This adds size to the muscle without proportional strength gains, creating a fuller, bulkier appearance. It is stimulated by more repetitions and moderate weights, promoting metabolic stress, so it is associated with bodybuilding style training. Both hypertrophy mechanisms are activated by resistance training, but their dominance depends on the training style. Low rep, heavy loads lead to myofibrillar hypertrophy, while high rep, moderate loads lead to sarcoplasmic hypertrophy. Combine low rep strength training with high rep hypertrophy sets for a well-rounded body. How does exercise cause muscle hypertrophy? Let's understand this step by step. First, mechanical tension. When you lift weights or perform resistance exercises, your muscles experience tension that disrupts their normal structure. This is the primary stimulus for muscle growth. Heavier loads and controlled time under tension amplify this effect. Second, muscle damage. The muscle tension produced by resistance training, particularly during eccentric or lowering or lengthening movements such as lowering weights, causes micro tears in muscle fibers. These tears might sound harmful, but they're actually your muscle signaling that they need to adapt to the workload. This damage activates the body's repair system and lays the groundwork for hypertrophy. Third, metabolic stress. High repetition, low rest exercises create a buildup of byproducts like lactate, which triggers a cascade of growth-promoting factors, including cell swelling and hormonal changes. Fourth, repair process. The repair process is where the magic happens. Once your muscle fibers are damaged, your body sends a cascade of signals to initiate healing. After exercise, your immune system releases inflammatory molecules to clear out damaged tissue. The body fuses these damaged fibers together and reinforces them, increasing their size and strength to better handle future loads. This repair not only strengthens individual fibers but also increases the number of myofibrils or contractile elements in muscle, resulting in thicker, stronger muscles. This process is why rest and recovery are as crucial as the workout itself. Without adequate recovery, this repair mechanism cannot function efficiently. Fifth, satellite cells activation. Muscles have a reserve of specialized cells called satellite cells, often referred to as muscle stem cells. These cells are activated when muscle fibers are damaged. Once activated, satellite cells multiply and fuse with the damaged muscle, donating their nuclei to the muscle fibers. Muscle fibers with more nuclei have a greater capacity for growth and repair because they can produce more proteins to support hypertrophy. This satellite cell activity is a major factor in long-term muscle growth and adaptation, especially for those progressing to heavier loads or more intense training. Sixth, protein synthesis. Muscle protein synthesis is the process by which the body repairs and builds muscle fibers. After your workout, your muscles are primed for increased protein synthesis. The amino acid leucine found in protein sources like eggs, chicken, and whey directly stimulates muscle protein synthesis by activating the mTOR pathway. Intense workouts also increase muscle protein breakdown. So for muscle growth to occur, muscle protein synthesis must exceed muscle protein breakdown. There is a heightened sensitivity to protein intake after exercise, often called the anabolic window. While not as short as previously believed, consuming 20 to 40 grams of high-quality protein within a few hours post-workout maximizes muscle protein synthesis. Lastly, hormonal response. Testosterone, growth hormone, and IGF-1 are key players in muscle growth. Resistance training increases these hormones, promoting protein synthesis and muscle repair. In essence, imagine your muscles as a construction site. Each workout creates minor damage to the building or muscle fibers. Satellite cells act as workers, bringing in new materials or nuclei, while protein synthesis provides the bricks and mortar to rebuild the structure stronger than before. It's important to remember that muscle growth doesn't occur during the workout. It happens afterward, during recovery. Sleep, hydration, and adequate nutrition play a huge role in optimizing hypertrophy. Besides normal muscle hypertrophy, is muscle hyperplasia possible? Muscle hyperplasia refers to the increase in the number of muscle fibers. Unlike muscle hypertrophy, which refers to the increase in the size of existing muscle fibers, hyperplasia involves the formation of new muscle fibers. While some studies in animals and isolated human cases, such as those with extreme conditions like bodybuilders or certain muscle injuries, suggest the possibility of hyperplasia, it is not widely considered a major contributor to muscle growth in typical human training scenarios. Hyperplasia, if it occurs in humans, is thought to be a much smaller contributor to overall muscle growth and might require very specific conditions, for example, extreme overload, injury, or genetic predisposition. Can you transform your muscles at the cellular level? Yes. Muscle plasticity refers to the ability of muscle tissue to adapt functionally and structurally to changing demands, such as exercise, injury, or altered use. This includes all types of changes ranging from short-term to long-term adaptations, such as functional, metabolic, and structural changes. Triggers for muscle plasticity include exercise, changes in workload, neural activity, and environmental factors such as hypoxia or aging. For example, transitions between muscle fiber types, increased mitochondrial density with aerobic training, and hypertrophy due to strength training. Muscle remodeling, a subset of muscle plasticity, refers to the structural and cellular reorganization of muscle tissue, often as a long-term adaptation to stimuli such as injury, disease, or prolonged training. It mainly involves long-term changes that require structural reorganization. Muscle remodeling, therefore, highlights recovery and adaptation following structural damage or persistent functional changes. For example, satellite cell activation and fusion during repair of damaged muscle fibers, changes in extracellular matrix composition or connective tissue during recovery or fibrosis, and muscle fiber regeneration or replacement in response to injury. Muscles therefore have an incredible ability to adapt to the specific demands placed upon them and to change in response to different stimuli, such as exercise, injury, or nutritional changes. Your muscle structure is genetically determined and the fiber types are largely fixed, but you can train to change and increase specific fiber types and develop specific characteristics in fibers depending on the stimulus. Your muscles can adapt and shift between fiber types based on your training. Endurance training, such as long-distance running, can increase the number of type 1 slow-twitch fibers or enhance their efficiency, improving stamina. Resistance training, such as weightlifting, primarily stimulates type 2 fast-twitch fibers, particularly type 2A and type 2X, promoting growth and power. Over time, there can also be a conversion of type 2X fast glycolytic fibers to type 2A fast oxidative glycolytic fibers, allowing for more endurance in muscles traditionally suited for explosive activities. For example, sprinters develop more fast-twitch fibers. Marathon runners develop more slow-twitch fibers. Your muscle fibers adapt dynamically depending on the type of exercise you perform and can develop specific characteristics such as increased mitochondrial density. For example, type 2 fibers can develop more endurance or strength traits depending on the stimulus. Muscle remodeling can slow with age due to reduced satellite cell activity and hormonal changes, which is why older individuals may experience less muscle growth from training compared to younger individuals. How can you train for muscle fiber transformation? For explosive power, train the type 2X fibers. Focus on heavy lifting and short sprints. Incorporate plyometric exercises like jump squats or box jumps. Heavy resistance and plyometric training increase motor unit recruitment and muscle fiber cross-sectional area, enhancing power output. For strength and size, train type 2A fibers. Use moderate weights with higher reps. Combine strength training with some cardio to maintain hybrid muscle functionality. This type of training increases muscle fiber size by promoting muscle protein synthesis and improving glycogen storage. For endurance, train type 1 fibers. Perform low-intensity, long-duration exercises like jogging, swimming, or cycling. Train consistently at a steady pace for extended periods. Slow-twitch fibers improve their oxidative capacity with endurance training. Over time, these fibers develop more mitochondria, better blood flow or capillary density, and greater fat utilization, which supports prolonged activity. Remember, while muscle fibers can adapt, genetic predisposition plays a role in determining your baseline fiber composition. Some individuals naturally have more fast-twitch fibers, which grow faster. Proper training maximizes your potential, but won't entirely transform one fiber type into another. Is the mind-muscle connection true? Yes. The nervous system plays an important role in muscle remodeling. Neuroplasticity or neurological adaptations occur early in strength training and involve improved communication between the brain and muscles. These adaptations help with motor unit recruitment, which enhances strength and coordination. As the body becomes more efficient at activating muscle fibers, strength increases even before significant hypertrophy occurs. So then, how can we maximize muscle growth? Maximizing muscle hypertrophy requires a combination of factors such as progressive overload, optimal training volume, nutrition, and recovery. First up, resistance training with progressive overload. Gradually increase the intensity, repetitions, and volume of your workouts. Gradually increase the weight you lift over time. This is crucial because your muscles need to be constantly challenged to grow. Try to add 2 to 5% more weight to your exercises every 1 to 2 weeks. If you reach the upper end of your target rep range, increase the number of reps you perform in the set. Gradually add more sets or exercises to your routine, increasing the total workload your muscles experience. Use different loads like heavy, moderate, light for different parts of your program. High-intensity techniques such as drop sets, supersets, and pyramid sets keep the muscles under constant tension. Without progressive overload, your muscles become accustomed to the workload, leading to stagnation in growth. Second, optimal rep range. For muscle hypertrophy, the most effective rep range tends to be 6 to 12 reps per set. This range maximizes the mechanical tension on the muscle fibers while also inducing metabolic stress. Focus on maintaining controlled tempo to ensure time under tension, which is critical for muscle growth. Third, training volume. For hypertrophy, aim for a total training volume of 10 to 20 sets per muscle group per week. This can be split across multiple sessions, like 3 to 4 sessions per muscle group per week. Incorporate compound exercises like squats, deadlifts, bench presses that recruit large muscle groups, and isolation exercises like bicep curls, tricep extensions to focus on specific muscles. Fourth, frequency of training. Training each muscle group 2 to 3 times per week allows for enough stimulus for hypertrophy while providing sufficient recovery time. Studies show that higher frequency results in greater muscle growth, especially for advanced lifters. Use a split training routine like upper body or lower body or push-pull legs to hit muscle groups multiple times a week. Fifth, rest between sets. Rest periods of 60 to 90 seconds between sets are generally ideal for hypertrophy. This duration allows enough recovery to perform the next set with high intensity while maintaining metabolic stress or lactic acid buildup. For compound movements with heavy weights such as squats, deadlifts, 2 to 3 minutes rest may be needed to ensure optimal performance. Shorter rests increase metabolic stress, while longer rests allow heavier lifts. Sixth, tempo and time under tension. Time under tension is the total time your muscle is under load during a set. Slowing down the eccentric or lowering phase of a lift increases STUT, which is important for hypertrophy. Use a controlled tempo with a 3-1-3 or 4-1-4 for each rep. For example, lowering the weight over 3 seconds and lifting it back up in 1 second. Seventh, cross-training. Relying on only one type of training can lead to imbalances and limit overall performance. Cross-training, the combination of different exercise modalities, ensures balanced development of all fiber types while reducing the risk of injury or overtraining. Combining different types of training, for example, strength plus endurance, ensures balanced fiber development. Overworking one type of fiber can lead to stagnation or injury. Cross-training helps distribute the workload across muscle groups and energy systems, allowing for better recovery and continuous growth. Eighth, nutrition. Muscle growth isn't just about what happens in the gym, it's heavily influenced by what you eat and how well you recover. Proper nutrition fuels your body, while recovery allows it to repair and strengthen, ensuring continuous progress. How to ensure a balanced nutritional diet? 1. Protein intake. Consume 1 to 2 grams of protein per kilogram of body weight per day to support muscle repair and growth. Protein is essential for muscle protein synthesis. Adjust your intake based on activity level. Higher for intense strength training and slightly lower for endurance-based activities. Rich sauces, lean meats, fish, eggs, dairy, tofu, legumes, and protein powders like whey and casein. Muscle protein synthesis is maximized when protein intake is spread evenly throughout the day, rather than taking it all at once. Aim for 20 to 40 grams of protein per meal and prioritize consuming a protein-rich meal or shake within 30 minutes of a workout. 2. Caloric surplus. To maximize muscle growth, consume more calories than you burn. Aim for a small caloric surplus, roughly 250 to 500 calories above maintenance, to ensure your body has enough fuel for muscle building. 3. Carbohydrates. Carbs are crucial for replenishing glycogen stores and fueling workouts. They prevent muscle breakdown and support recovery, especially after intense workouts. Aim to consume complex carbs like quinoa, oats, sweet potatoes, brown rice, whole grain bread, bananas and berries around your workouts for optimal performance and recovery. Focus on pre-workout carbs 1 to 2 hours before a workout to improve performance, and post-workout carbs immediately after a workout to restore energy levels. Combining carbs with protein post-workout, for example, a smoothie with whey protein and a banana, enhances glycogen replenishment and muscle repair. 4. Healthy fats. Ensure adequate intake of healthy fats like avocados, nuts, and olive oil for hormone regulation, particularly for testosterone production. 5. Stay hydrated. Water supports nutrient transport and muscle function. Aim for at least 2 to 3 liters of water daily. 9th, recovery and sleep. Muscles grow during rest, not while training. Adequate rest is crucial for allowing muscles to repair and grow. Avoid overtraining and ensure 48 to 72 hours of recovery between working the same muscle group. Incorporate light activities like walking, yoga, or stretching on rest days to promote blood flow and reduce muscle soreness. Aim for 7 to 9 hours of quality sleep per night to optimize recovery and performance. Sleep is essential for muscle recovery and growth, as growth hormone secretion is higher during deep sleep. Sleep deprivation significantly reduces protein synthesis and muscle repair, hindering performance and long-term progress. 10th, optional supplementation. It is advisable to get all nutrients from natural foods. If not possible, choose supplements such as whey protein, casein protein, BCAA, creatine monohydrate, and beta-alanine from reputable, regulated brands. To learn more about supplements, you can watch our video on the science of muscle-building supplements. 11th, optimize your hormones. Hormones are the body's chemical messengers, and they play a critical role in regulating muscle growth, repair, and recovery. Testosterone, often called the muscle-building hormone, is essential for muscle growth. It increases protein synthesis, stimulates the activation of satellite cells, and increases nitrogen retention in muscles, which helps maintain an anabolic growth-promoting environment. You can boost testosterone naturally by performing heavy, compound lifting like squats and deadlifts, prioritizing 7 to 9 hours of sleep since testosterone levels peak during deep sleep, and consuming healthy fats like avocados, nuts, and olive oil. Growth hormone is secreted by the pituitary gland and influences muscle growth, recovery, and fat metabolism. Growth hormone stimulates cell proliferation and tissue repair, promotes fat metabolism, helps your body use stored fat as energy during exercise and recovery, and works synergistically with testosterone to enhance protein synthesis and muscle repair. You can increase growth hormone naturally by incorporating high-intensity interval training and resistance training, by optimizing sleep, as GH secretion is highest during the deeper stages of sleep, and by eating arginine-rich foods such as turkey, spinach, as arginine supports GH release. Cortisol, known as the stress hormone, is essential for energy regulation, but can be harmful if levels remain high. In small amounts, cortisol helps mobilize energy by breaking down glycogen and fat. Chronic high cortisol levels, however, promote muscle protein breakdown, hindering growth and recovery. You can manage cortisol levels by avoiding excessive training as it increases cortisol levels. Practice stress management techniques such as meditation, deep breathing, or yoga, and ensure adequate rest and relaxation between intense workouts. In essence, to naturally optimize your hormonal levels for optimal muscle growth, focus on consistency in training, a nutritious diet, adequate sleep, stress management, and healthy lifestyle choices. Over time, these strategies can help maximize anabolic hormones like testosterone, growth hormone, while minimizing catabolic hormones like cortisol, resulting in optimal muscle growth. Lastly, mind-muscle connection. Focusing on the mind-muscle connection involves actively concentrating on the targeted muscle during each exercise. This mental focus can enhance muscle activation and lead to better training outcomes. By combining these strategies, you can maximize muscle hypertrophy and make significant gains over time. Remember, the time you spend outside the gym is just as important as the time you spend inside it. So there you have it. Your muscles are incredible, dynamic structures capable of adapting to the demands you place on them. By understanding the science of muscle fiber growth and tailoring your workouts, nutrition, and recovery, you can achieve your unique fitness goals, whether it's building explosive power, enduring stamina, or a combination of both. Remember, train smarter, not just harder. Keep pushing, and remember, your muscles are transforming with every rep. See you in the next video. Till then, take care of yourself.